That's what I got. That's what I got for number 6.
Right?
All right.
No. Like, that answer is what I got for 6.
Oh, that's the same answer to both of them?
Roughly, yeah.
Okay. There were some good discussions there. I want you to understand that we are jumping right in. I mean, this is question 6 is calculus. The word instantaneous right there. Okay? When we go on question 5, which talks about average rate of change, that right there is algebra 1. Right? Instantaneous rate of change, that is calculus. Okay? Now, how do we calculate those things, right? How do we do those? This is going to be it. You'll see how well this laptop picks up my voice. Probably not. So when we look at this graph, all right, you were asked, is the door opening or closing at 1 second, right? Was that question 4? Yeah. Is the door opening or closing at 1 second? And so we said we could go on here and we could trace. Oops. We could trace at 1. And right there is, and so what'd you say? Opening. How can you tell? The graph is still going up. Now, some of you might have looked at the table. Now, the table doesn't tell you quite as much, does it? What's the table say? At 1 second, it's 100 degrees. At 2 seconds, 100 degrees. So just from that information, who knows what's happening, right? It might have just be stopped from 1 to 2 seconds. It's 100 degrees open. It just stopped. But that's actually not what happened, right? If we, by looking at the graph, we can tell it kept opening until 1.5 or something in there, somewhere in there. And then it started to what? Close again, right? When the graph's going down, the door's closing. So you can picture this. It swings open. We should back up a little bit. Did anybody have a graph remotely like this one? Kind of, right? But no. Okay, but it swings open, and usually you imagine these doors, they swing open pretty fast, so you throw it open, so it goes up really fast. So, okay, so now think algebra 1. So what about that graph from 0 to 1 tells me that they swung that door open fast?
Because it went in a second.
Steep would be the word I would think of. Yeah, it went very quickly, but it's visually, it's steepness, right? It's steepness. Later, as the door is closing, it's pretty slow, right? Those doors, you kind of, like a screen door or something, it kind of comes and it stops and then it just kind of slowly shuts, right? So, now, what concept in algebra measured steepness? The slope. Slope is a huge part of calculus. That is what we're going to be talking about. Now, here's the difference. And here's what you were supposed to do in question 5. Question 5 said, find the average rate of change between 1 and 1.1 seconds, right? Somebody want to volunteer and tell us what they did? Calculation, Matthew?
Well, I figured out the slope of the line between 1 and 1.1. And I found the points values, so it's 1 to 100, and 1.1 is 103.
Exactly 103? Mm-hmm. Was that on the calculator?
Yeah.
On the graph screen?
Yeah.
Okay. And go ahead.
And then I did rise over run, which is 103 minus 100 over 1.1 minus 1. So it'd be 3 over 0.1, which is 30 degrees per second.
Okay? Mm-hmm. That's perfect. Now,
because it's 3 over 0.1, which 3 divided by 0.1 is 30.
Is 30, right. That is average rate of change is slope. And I'm going to say that over and over this year. The word average in calculus is not like the word average that you normally think of. When you think of average, you think of adding some stuff up and dividing by how many you have. That's not what we're doing. Average rate of change is the slope between 2 points. Average rate of change is the slope between 2 points. And that's exactly what, because what this is saying is it went 3 degrees in 0.1 seconds, right? It went 3 degrees in 1.1 seconds. So the average rate of change is 30 degrees per second. Now, the other thing, going back to that graph, what is the door doing speed-wise from 0 to 1 second? Swinging open, but speed-wise. How fast?
100 degrees.
Pretty fast.
100 degrees per second.
Well, okay, between 0 and 1, it's 100 degrees per second because it goes 100 degrees in 1 second. But I'm saying as that graph goes up and starts leveling off, what's happening to the door? Slowing down. That's my point, right? So between 1 and 1.1 even, it's slowing down, right? So now let's think about this. So you just told me the average rate of change is 30 degrees. I heard some people talking, they got the same answer for number 6. But now think about that. Can that be right?
No. Has to be a little faster.
Doesn't it have to be a little faster? Think about this. If we just said the average rate of change between 1 and 1.1 is 30 degrees per second, but it's slowing down, that means at 1, it had to be going faster than it was at 1.1, right? So if the average between 1 and 1.1 is 30, then at 1 it had to be going a little faster than 30, right? So how could we calculate that? What's the problem with trying to calculate the slope at 1 second? We only have 1 point. Man, plug that in and remember that. There is the difference from Algebra 1 to calculus. What we want to find in calculus is, think about it. If the cop pulls you over for speeding, he's not going to pull you over because you're average speed, right? He's going to say, when you went by me, at this instant, you were going this fast, right? And that's hard to find, especially if you're varying your speed. If you're going a constant acceleration, some of you may be in physics. In physics, you've got a lot of different formulas about velocity and things like that. But those almost all have to do with constant acceleration. If we have a varying acceleration, which is what we would have in a problem like this, then how do you find that speed at these instants? Because the slope formula needs 2 points, doesn't it? All right, so let's take a look at that a little further. So what we're trying to find here, let me see if I can get this to work here. Okay, so now I'm gonna take some liberties here. So this is 1, and let's pretend 1.1 is here. You guys found this, the slope of this line right here, right? That's terrible. That's called a secant line, right? Goes through 2 points.
Yeah.
Now, when in number 6, when we want to find the instantaneous rate of change, we want to find the slope of this line right here at 1. Wouldn't it have to be just a little bit steeper? Right? Because that's leveling off, isn't it? So that green line would be the slope at 1. The problem is it only touches the curve in 1 point. What do we call that when we have a line that touches a curve at 1 point? Tangent line. It intersects too, but it's a tangent line. You do that geometry with circles, right? When lines that just touch a tangent. What we're going to be interested in is the slope of the tangent line. Now, I don't expect you to know this. This is an exploration. What I like to do is I like to start out the first couple days talking about the big ideas that we're going to be addressing as we go through calculus. But we will then be diving into the details of all this later on. So don't worry about taking a bunch of notes and writing down all these things I'm saying right now. Okay? I'm just trying to give you a sense of what it is we're going to be studying this year and what it is we're going to be working on. Okay? Now, it's hard to imagine, but this concept of the slope of a tangent to a curve, this concept of instantaneous rate of change, we're going to study the effects of that and the uses of that through February. Okay? It seems amazing that there'd be that many things that would depend on this, but there won't. Okay? All right, so It's got to be a little steeper. So now the question is, how in the world could you calculate it? All right, now we're going to use some notation to make it easier for ourselves. So in our calculators, we call this F1, right, when we typed it in. So go ahead and get your calculators out. We call that F1 of X is where we typed it. So I'm going to rewrite Matthew's slope formula he told me. And he said he did he basically did this calculation right here. Would you agree with me that that's what he did? Right? And got 30. Now, let's go on to our calculators and do that. So now, actually, we need F1 in here. We need a 1 in there because that's what your calculator is. So go on your calculator screen, and I want you to type in parentheses. So hit the scratch pad key right underneath escape, and you get on that blank page. That's your calculator. Okay, I want you to type F1. Well, you need a left parenthesis. I'm sorry. Left parenthesis. F1 of, right, 1.1. Maybe I should just go there. Okay, so I'm going to get on my scratch pad. I'm going to go left parenthesis, F1. Notice how it went bold because it knows there's something there. 1.1. I'm going to right arrow. Right arrow's on the trackpad. If you push the right edge of the trackpad, that's the right arrow. So F1 of 1.1 minus F1 parenthesis 1. And then I'm going to right arrow past both those. Then I'm going to hit divide. Now I'll show you what I could have done instead of doing the parentheses here in a second. But I'm going to hit divide. Now I'm going to hit a left parenthesis. And then I'm going to go 1.1 minus 1. And I'm going to hit enter. Wait a minute. I thought we were making it 30. Here's what happened. On the graph screen, you're limited to 3 digits. So when you guys trace out 1.1, and you got 103, it rounded. So that was not accurate. So what you did was fine, but we would normally not get values off of the graph screen because they're not accurate, right? Because you're limited on how many decimals you get. We're going to talk about settings on the calculator tomorrow, so we'll mess with that. So here's where we would want to do it. So basically this does it all for me in one step. It plugs the numbers into the function, gets the y's, and divides by the x's. Okay, now, that's the instantaneous rate between 1 and 1.1. I want the rate right at 1. That's only 1 point. How could I adjust this? How could I adjust this formula right here? And by the way, what you can do is you can arrow up. No, arrow back, left arrow. Is that? No. I thought I could. There we go. Up arrow. Grab that. Hit enter. It'll paste it back down there, and then I can adjust that. So that's too small, right? That's too small of an answer. It's actually faster at 1. So how can we be more accurate? I mean, well, let me say this. What if I would have said do it between 1 and 1.5? What kind of answer? Let's say 1.5 is up near the top. What kind of answer would we have got compared to this? Smaller. It wouldn't have been any good, right? And if I'd asked you then, how could you be more accurate if we want to know how fast it was at 1? Well, somebody might have said, well, how about if you go from 1 to 1.1? That'd be better. Isn't that closer to 1? Okay, and here it is. And then I'd say again, how could we do even better? Huh? Well, we can't make it at 1 because I need 2 points.
1.0.
Aha! Let's do that. Let's left arrow back here and let's stick a 0 in there. Everybody see what I did? I up arrowed, right? I up arrowed there, grab that thing, and now I'm going to change that to 1.01. But now I got to come down here and change it down here too. 1.01. Right? Wouldn't that be, think what that's going to do? That's going to find out how far open the door is at 1.01, how far open it was at 1. Subtract those. That's how many degrees it went between 1 and 1.01. What do we get? Now, that's still too slow. That's not the speed at 1. So how can we get better? Okay, so I'm going to arrow up. So that's highlighted. I'm going to hit enter. Now I'm going to left arrow, and now I'm going to get right. Put my cursor right in there, and then I'm just going to type. Let's type like 3 zeros. So we now have 4 zeros in there. And then I'm going to arrow down here, and I want to put 3 more zeros in there. Right? Still too slow. But man, it's got to be close, right? Let's put, I'm not even sure, I'll be honest, I'm not, well, let's try it. So let me up arrow and grab that again. So these are just some little tricks I'm trying to show you too with the calculator, how we can do some calculation, but let's do a couple of zeros. I'm just going to put 2 more in there. Okay, still changing. However, it's not changing very much. Would you have some confidence in giving me an answer right now for the speed at 1 second? What would you have confidence in saying?
The speed at 1.0000000.
Well, okay, yeah. No, you're right. I mean, that would be that. But no, I mean, what would you have confidence saying the speed at 1?
The speed at 1 is approximately 30.6853.
It. Yeah, I'm not sure I'd go as far as 6853.
6.8.
Would you have confidence in 6.8?
Yeah.
Or 6? Now, or 7 maybe if you want to round. Because if I keep going with zeros, is that 6 going to stay?
Yeah.
I think it is. The 8?
Yeah.
Now here, that might change. It went 4, now it's 5. We said it should get a little higher. I don't know that it'll go to 6. You know, and would it go enough that that 8 would change to a 9? I don't know, but we can do a few more zeros and we can try it. Now, again, right now my calculator is set to only show 4 decimal, or not decimal places, but 4 digits, or excuse me, 6 digits total, and I'm going to talk about those settings tomorrow. So at some point, that's not going to change. We put a few more zeros in, and they're just not going to change. So, if you're waiting for me to give you some special formula for how to do the rate of change instantaneously, I ain't gonna. There isn't one. Well, there is, but we're going to have to develop it from what we just did right there. The way you find the slope at 1 point is you don't find the slope at 1 point. You find the slope at 2 points, but you let those 2 points be really, really infinitely close together. Okay, that is probably the theme of the year of calculus, to be honest with you. We're going to look at a variety of things where it's going to be, we want to find this value of a changing quantity. Matter of fact, calculus is often called the mathematics of change. We're going to be looking at trying to find a value at a certain point in time when it's changing the whole time. How do we find that value? And usually the way we approach it is we do better and better estimations. We do better and better approximations. So this idea of instantaneous rate of change is a big one for one of the things we're going to do. Okay, so very good. For tomorrow, well, you've got half of it done right there, and that was that assignment. So the rest of your assignment is that Google Classroom. Okay, the course description, questions, right? So when you get on there, okay, so when you get on there, here's the course description, you open that up, here's the question, so you read through, and it's just going to ask you, it's kind of like a study guide, it's going to make you go through and search through the document, find some things. I kind of picked out what I think are the important parts of that course description so we get kind of familiar with a few of the things that are going on here. Okay? And make sure you hit turn in. I think I got that set to be due at 10:10 or whatever time our class starts. So make sure you've typed in the answers to those questions, and you've hit the turn in button up at the top of the document. Okay?
This packet.
Nope, just the front page of that packet's all we wanted. So up through number 6. So and that course description question. That's all for tomorrow. Okay? I don't want to kill you off the first day.
I was gonna say.
I always wait till after the drop deadline, and then I really start. Then I start hammering.
See, Miss Payne was the other way around.
She was the other way
She was
around.
so smart.
You're right up there.
Yeah, she was.
I did like 3 different times.
Okay, here is a problem. See how that didn't go bold right here? What happened is it's because you didn't put in your graph. So, in other words, see, I don't know where it did. So if we go 200, what was it, 200 x times 2 raised to the negative x, enter. And now if you go back to the screen, what the graph is. See how those turn bold in that. Now, hey, listen up. Now, keep in mind, the only reason we were able to put in that F notation in our calculator, that F1, is because we had put the function in to our graph screen, so it was defined to be that equation. Okay, so that's why that works. So there'll be times where we'll do that again, but we'll talk more about the calculator. Did I get all the info sheets from everybody?
I do, but I don't. So. What? Because they put me in Inline study, but I have to get out of it. Hey, Mr. Clark.
Yeah.
Big question for you.
No.
I know you don't know. This is dude's big. I know.
Tell you what. I told my son when he went to college this year, I said, that was a mistake I made. Gotcha. Done. You bet.
I appreciate it. Because I want to. I know. It's already a hard time. What? How does that happen?
What's 7 plus 11? 23. This guy sounds like he challenges me.
I get 65. I wore a beard and I'm like, I'm so lonely. This is like my life right here. Why am I so lonely? Wow, Maddie.